acid-base indicator. A scale for measuring hydrogen ion concentration in an ionic aqueous solution of acids and bases was developed by Danish biochemist Sørensen. He was interested in checking the acidity of beer and introduced a scale known as pH scale. In German, P stands for potens, meaning power. The scale ranges from 0 to 14, and the characteristics can be listed as: acids have pH less than 7. The more acidic is a solution, lesser will be the pH. Neutral solutions have pH of 7. Alkalis have pH more than 7. The more alkaline is a solution, higher will be its pH. Universal indicators for pH values. Papers impregnated with universal indicator have been developed to predict pH of different solutions. On comparison with charts showing different colors, pH can be predicted. If color of strip is yellow, this means that pH of the solution ranges between 6 to 7. Universal indicator solutions are also available to predict pH. 1 or 2 drops of indicator are added to solution taken in a test tube. The solution acquires specific color which can predict pH value. Activity. Let us find the nature of certain solutions such as dilute hydrochloric acid, acetic acid, ammonium hydroxide and sodium hydroxide taken in a test tube labeled as A, B, C and D. Now, add 1 or 2 drops of universal indicator solution and note the changes taking place. Solution A develops red color. It is a strongly acidic solution. Solution B acquires yellow color. It is a weakly acidic solution. Solution C develops blue color. It is a weakly basic solution. And solution D attains dark violet color. It is a strongly basic solution. Relation between pH value and hydrogen ion concentration. pH also is defined as negative logarithm of the concentration of hydrogen ions. That is, pH is equal to minus log of hydrogen ion concentration. Hydrogen ion concentration is equal to concentration of hydrogen ion in its solutions in moles per liter. On this basis, pH scale of 0 to 14 was established. pH equals 0, that is, highly acidic. pH equals 7 means neutral. pH equals 14 means highly basic. Solutions having pH less than 7 are acidic. Lower the value of pH, more is the concentration of hydrogen ions in the solution. Solution having a pH less than 7 changes the color of blue litmus to red. These are acidic solutions. Solutions having pH more than 7 are alkaline. Higher the value of pH, the more is the concentration of hydroxyl ions. Solutions having pH more than 7 change the color of red litmus paper to blue. Solutions having pH more than 7 are alkaline. Importance of pH in our everyday life. Plants and animals are sensitive to pH changes around their environment. pH in soil. Most plants grow in soil having pH close to 7. For healthy growth of plant, pH should be neither acidic nor alkaline, because either of them do not allow the growth of plants. We also find that color of hydrangeas depends on the pH of the soil in which they grow. If pH of soil is acidic, flowers are blue, and in alkaline pH, flowers are pink. pH of solutions can be found out using paper strips. We take 2 to 3 grams of soil sample in a test tube and add 5 to 10 ml of water to it. Shake thoroughly and allow the heavier clay particles to settle. Dip the pH paper strip in the solution. Compare the color of the pH paper strip with the standard color chart. If pH strip becomes red, it indicates that the pH of the soil is too acidic. To correct the pH of the soil, basic substances like calcium oxides, calcium carbonate, or calcium hydroxide can be added to bring the pH of the soil close to 7. If pH of the paper strip turns blue, it indicates that the pH of the soil is too basic. To correct the pH of the soil, acid phosphates can be added to bring the pH of the soil close to 7. Use of pH in environmental issues. pH of rainwater can be detected by dipping a pH paper in rainwater. If it shows a pH range between 3 to 4, then it is acidic in nature. This is called acid rain. Acid rain means deposition of acidic components in rain, fog, dew, or dust particles. This is called acid precipitation. Clean or unpolluted rain is slightly acidic, its pH being about 5.6. Because carbon dioxide and water in the air react together to form carbonic acid, which is a weak acid. The extra acidity in rain comes from the pollutants in air, such as sulfur oxides and nitrogen oxides with water in the air to form strong acids like sulfuric and nitric acid. This acidic rainwater harms the crops and also decreases the pH of river water. Aquatic animals like fish cannot survive in acidic water. This can lead to environmental problems. Environmentalists insist that pH value of water should be in the range of 6 to 9. Acid rain is a major problem near industrial establishments and big cities, where pollution due to exhaust gases from automobiles is quite high. The acidic fumes of sulfur dioxide, sulfur trioxides, and oxides of nitrogen make the rainwater acidic. Importance of pH in human beings. pH of saliva is between 6.5 and 7.5. The pH of the contents of stomach is between 1 and 3. The pH of the blood is nearly 7.4 and is constant. Any change in pH value beyond permissible limits is indicative of a serious problem. pH in our digestive system. Our stomach produces hydrochloric acid having pH range of 1 to 3. It helps in the digestion of food without harming the stomach. Overeating or eating fried foods can cause hyperacidity. Hyperacidity means production of excess hydrochloric acid by the stomach. This can cause pain and irritation. To get rid of this pain, people use bases called antacids. These antacids neutralize the excess acid produced by the stomach. Magnesium hydroxide, also called milk of magnesia or sodium hydrogen carbonate, also called baking soda, acts as mild base, often used for this purpose. pH change as the cause of tooth decay. If the pH of saliva in mouth is lower than 5.5, it can cause tooth decay. Eating sugar, chocolates can cause tooth decay. Bacteria produced in the mouth produce acids by degradation of sugar particles left in the mouth after eating chocolates. The acid produced lower the pH of the mouth to less than 5.5. At such a low pH, the tooth enamel gets corroded. Tooth enamel is actually a protective hard coating of calcium phosphate. At pH lower than 5.5, the insoluble protective hard coating of calcium phosphate on teeth is attacked by acid and gets corroded. This is when the tooth decay process starts. It is advisable to clean thoroughly all sugar or food particles stuck up in mouth by drinking plenty of water. We can use toothpaste which contains some basic substances to neutralize the excess of acid produced in the mouth and prevent tooth decay. Importance of pH in self-defense by animals and plants through chemical warfare. Honeybee protects itself by injecting acid in the skin of a person when it feels threatened. This causes pain and irritation to the person who is stung. Use of a mild base like baking soda on the stung area gives relief. Some plants like nettle have leaves like stinging hair. If one touches stinging hairs of nettle plant leaves, it causes burning and irritating sensation. This is due to methanoic acid secreted by stinging hairs. A traditional remedy is rubbing off affected area by dog plant, which is basic in nature. Dog plants generally grow besides nettle plants.